Hey guys, welcome to the 15th tutorial of data structures, and in this tutorial we are going to see the applications of stack part 1. Okay, and applications of stack, there are several applications of stack available in day-to-day life, and the most important application are listed as below. And let's discuss few applications of stack, such as balancing the symbols, where we can take an expression and we will check whether the symbols and the parentheses are balanced or not using a stack. And 8 queen problem. 8 queen problem is the queen term mentioned in this category is nothing but a queen in a chess game, where a queen is being used, and the powers of queen is that a queen can move entire throughout the chessboard in any direction, in any particular direction, in any number of times, right? So what happens when several queens are placed in a single chessboard and where each queen doesn't cut another queen? Okay, so there are several categories, like 4 queen problem is there, 8 queen problem is there, and even 16 queen problem is also there. We are going to see whether how to solve the 8 queen problem using a stack. And next one is Tavern of Hanoi. So Tavern of Hanoi is nothing but we will be having 3 terms of towers, and in a stack method where only one top is available and the bottom is being closed, and the one tower will be having 3 circular discs at different sizes, where the largest size is available at the bottom, the middle, the average size is placed in between, and the smallest disc is being placed at the top. What we have to do is we have to replicate the same model in another tower by moving one disc at a time. And similarly, the condition is that only the smallest disc must be on top and largest disc must be in bottom in any cases. Okay, so this is Tavern of Hanoi. Okay, and next one is function call. Function call is nothing but a processing element available in a system, where the list of instruction given to a function call states that the last function called first gets completed first. So if we are calling a function within a function, a function within a function within a function, the last function called completes the first one, and the first function called completes the last one. Okay, and last one is evaluating an arithmetic expression. So this is used to convert an infix expression into a postfix expression. Okay, so this process has a step of procedures and instructions when we are implementing the same with the help of a stack. Okay, and let's discuss few of these applications right now. Okay. So guys, so far we have seen the applications of stack. In this list of applications of stack, today we are going to discuss 2 applications of stack, which are balancing the symbols and 8 queen problem. So in balancing symbols, first of all, we are using an expression and checking whether the expression is being balanced or not. For example, we are taking an expression as a plus b, okay, and we are inserting an hash symbol to indicate that this is the end of the expression. Okay, so as this is the end of the expression, we are ending it over here, and what we are going to check is whether the equation is balanced or the expression is balanced or not by checking whether the number of parentheses opened and number of parentheses closed are equal. And how to check that? By means of a stack. So we are using a stack, yes, okay, and we are reading each character one by one. Okay, so initially we are reading the first character, open parenthesis, so which is inserted in the stack. Okay, and only parentheses have been inserted in the stack and other elements are just read out and thrown out to the output. Okay, so the next character is a, which is read as it is, and next is the operator plus, which is read as it is, and next one is element b. Okay, so far we have read 4 characters, and the last character is close parenthesis. So close parenthesis means we have to insert it into the stack, so we are inserting it into the stack. So once we have written close parenthesis, what we have to do is we have to pop 2 elements. We have to pop this set of parentheses out of the stack. Okay, so now the stack is empty after popping the parenthesis. So, and finally we have reached to the end of the expression. So while reaching the end of the expression, if we are having an empty stack, it means that the equation of the symbol is being balanced. Okay, so it is a balanced expression. So this is how we are using stack ADT for balancing the symbols. Okay, let's take another example. Like for example, a plus b into a minus b. Okay, so we are reading this equation into the stack. So first we are selecting the character open parenthesis. Okay, and then we are reading element a plus and b, which is read as it is, and then we are choosing the next character close parenthesis. So we are again inserting the close parenthesis. So once we have received a close parenthesis, we can pop the set of open parenthesis and close parenthesis. So we are popping it out. Okay, and then moving on to the next character asterisk, and then again we are reading two characters, one by one. So first we are using an open parenthesis, and then we are using another open parenthesis. Now we have two open parentheses inside the stack. Okay, the next element a is being read, minus is being read, and b is also being read, and again we are reading the element close parenthesis. Okay, so once close parenthesis is there, we can eliminate or we can pop a set of parentheses, so which is being popped out, and we have reached to the end of the expression, and still we are having one symbol inside the stack, which means that this is not a balanced expression. So this is how we are implementing stack ADT in balancing the symbols. Okay, so now moving on to the next application. So the next application is called as 8 queen problem. So where we are going to insert 8 queens inside a chessboard with the dimensions of 8 cross 8 matrix, and in such a way that each queen doesn't neglect or doesn't cut another queen. Okay, for example, I will explain it to you with the 4 queen problem. So we are having a 4 cross 4 matrix over here, 1, 2, 3 and 4. Okay, so in this 4 cross 4 matrix, we are going to insert 4 queens in such a way that each queen doesn't cut another queen. Okay, so for example, I am inserting the first queen in the first cell, Q1. Okay, and then I am going to, if I have inserted the queen, then it means that it can cut the elements in these values. Okay, so I can't insert the elements in these cells. So next process, I have to take another value, next position, for example Q2. So I am inserting this queen into the stack. Okay, so it means that I cannot insert the elements in added these positions also. Okay, so finally I can't insert even in these values. So I can insert over here, but I can't insert the next value, so which is already a mistake over here. So what I am going to do is I am going to backtrack the problem. So can you understand what I am saying? So I have inserted the first queen over here and neglected all the other parts where it could cut the other cells. Okay, so what we have done so far is we have inserted the first queen, and we have inserted the same queen inside the stack, and we are inserting the second element queen over here. But it is unfortunate that we couldn't add any other queens further. So we are removing the last inserted queen from the stack. So last queen inserted is the first queen to get out. So last in first out concept, which is a stack concept. So what we are doing is we are altering the position of the queen, which is being replaced again. So we are from this place, we are moving the queen to the another place. Okay, so as we are putting this queen, and again we are inserting the same queen inside the stack. Okay, and then again we are neglecting the same values. Okay, and now we have a value over here. So we are inserting the queen again over here, and again the fourth queen is not possible to be inserted. So what we are doing is we are again backtracking, we are removing the last queen which has been inserted. Okay, so this is the way we are doing a 4 queen problem sum. Similarly, in 8 queen problem, we will be having a 8 cross 8 matrix, and we have to insert 8 queens together. So this is a 8 cross 8 matrix, and let's assume that we have a queue over here and we are going to insert 8 queens in this segment. Okay, and initially we are inserting one queen, the first queen, and same queen has been inserted into the stack. Okay, and so we are now neglecting the places where this queen has the power to cut its enemies. Okay, so we can't insert the queen, other 7 queens in these dotted positions. So we are going for the next queen. So Q2. Okay, and similarly we are going to insert all other queens. Okay, so at the end of stage, the 8 queen problem is nothing but we are going to insert the 8 queens where the 8 queens are being inserted into the stack, as each queen doesn't cut any other queen. Okay, if there is a collision or if there is any dead end, what we do is we backtrack the position, and we delete or remove the last inserted queen first. Okay, and then select an alternate path to select those queens. Okay, so this problem is called as 8 queen problem. Okay, where all the 8 queens are being placed with the help of a stack inside a 8 cross 8 matrix. Okay, and the final solution for this 8 queen problem is, so this is the final solution of 8 queen problem, which is an application of stack, and the 8 queens can be easily remembered with the keywords of rows and columns. Like for example, the first queen is being inserted in the position where first row, second column, and the second queen is being inserted in the second row, fourth column. So similarly 3, 6, 4, 8. Okay, and 5, 3, 6, 1, 7, 7, and 8, 5. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 rows and 2, 4, 6, 8, 3, 1, 7, 5. That is a number you have to remember if you want to write the same answer in the final exam. Okay, so this is 8 queen problem, and this is the solution to easily remember for this application of stack. Okay, and the remaining applications will be discussed in the next tutorial. So until we meet in the next tutorial, it's Karthikeyan signing off.